Hello and welcome to today's webinar, which is on unlocking the power of IoT with 5G Standalone. My name is Jeremy Cowan. I am the co-founder of IoT Now, and it's my pleasure to be your moderator today. Thank you all for joining us around the world, wherever we find you. We're proud to bring you this webinar with Qualcomm and their partners, Ericsson and HMS Networks. Today, we're looking at commercialization of the first 5G standalone network in Germany. April 2021 marked a bit of a milestone in the development of 5G in Europe. For those not familiar with it, 5G standalone, also called 5G SA, is the critical step in 5G's development as it decouples 5G from 4G. And in doing so, it unleashes 5G's full power. It's offering users low latency, high-speed connectivity, and enabling a wide range of innovative 5G applications. So in today's webinar, we're going to hear from leading experts what this could mean for your industrial applications that span sectors as varied as retail, manufacturing, and healthcare. So without further ado, let me introduce our experts right now. They are Sebastiano Di Filippo, Senior Director for Business Development at Qualcomm IoT Europe. And it's really good to have you here again, Sebastiano.
Great to be here, Jeremy.
And next, let me introduce Dr. Jens Jakobsen, who is Development Manager at HMS Networks. Thank you for joining us, Jens.
Yeah, thank you very much, Jeremy.
Finally, it's my absolute pleasure to welcome Jan Diekman from Ericsson's 5G Business Development and Partnerships, where he is the manager. Jan, great to have you here.
Thank you very much. Happy to be here, Jeremy.
Well, thank you all. Now, don't forget, everyone, as usual, this webinar is being recorded. And from tomorrow, you can access the audio and slides at iot-now.com. In a moment, we'll have a poll, so you can tell us what you're up to. And don't worry, the answers are absolutely confidential. None of us can see your individual response. So please tell us what's on your mind. And later on, I'll be putting questions to our panel. I want to make sure that we find out the answers to the questions that you are putting. So send me your questions starting right now. Just click on the sidebar icon at the top right of your screen if you haven't already, and you'll find a white panel which will show you the polls and every information you need there. Then just type your questions into the window under the questions tab, and we'll discuss as many as there's time for. Of course, any that we don't get to will be passed to our panel to answer later. And of course, if you have any technical issues with your audio or slides, you can also use the question window to get help from our technical support team. Now, if you take part in the poll, you will see the answers. If you choose not to, I'm afraid you won't see the answers, but we're looking for everyone to take part. So click on the poll tab and you should see that coming up now. Which sectors would you like to learn more about and understand more of the technological solutions that are now available? Are you looking for information in utilities, retail, manufacturing, logistics, or healthcare, or more than one? You can tick any or all of those. So, which sectors would you like to learn more about and understand the technology solutions available? And let's start to see what replies we're getting. Already, I'm seeing a fairly strong lead for manufacturing, showing currently 31%. And the lowest figure is retail at 13%, with equal figures for logistics and utilities at 18% and healthcare at 21%. I'm sure that's going to fluctuate a little bit as we get more and more people submitting their replies. But Sebastiano, is that kind of in line with your expectations?
Yeah, I think so, and there is a clear dominance in the feedback we got on the manufacturing area, which is quite expected because this is one of the major trends. Good to see that a lot of people is interested to understand the role of 5G technology in areas such as retail and logistics, where we see a lot of potential, even utilities, where the need for more intelligent and better connectivity technology to make the smart grid network more intelligent is something that we are detecting as one of the major trends as well.
Definitely. Well, I'm sure that will continue to evolve, and we'll keep that poll open during the webinar so that people can come to that later. I'm also going to be welcoming your questions at any point. So if you've got questions on anything that you hear during the event, use the questions tab to send us your questions at any time during the webinar, and we'll do our best to get to as many as we can at the end. We have a strong attendance today, so I'm not sure how many we'll manage, but it'll be the largest number we can do. So without further ado, let me now hand over to Sebastiano. The floor is yours.
Thank you very much, Jeremy. This is the title of the presentation that is trying to explain, which is the objective of today's webinar, right? We want to cover 5G technology, explain what XA is and which way XA can really help the IoT market and the segments and verticals that we will cover in order to move the adoption of technology to the next level, bringing savings, optimization, and new use cases. 5G technology has been identified as one of the major enablers for new market potential. There are independent studies, such as the one from IHS Markit, that are indicating in $13 trillion the value that will be generated by the 5G industry by 2035. So even more important than that is the segments that we believe and market reports believe will be heavily impacted by the adoption of 5G technology in a positive way. So this somehow reflected also is also quite coherent with the outcome of the poll session we had a few minutes ago, because if we look at the markets where 5G technology can really help disrupt and bring a lot of benefit, we will start from smart manufacturing, where there is a lot of value that will be generated by having support from the 5G technology in implementing the vision of the factory of the future. But I would like to mention also other applications that for various reasons can greatly benefit from 5G technology. One is the retail one, where a lot of intelligence will be required both to improve and optimize and make more efficient the logistics aspect of the retail market, but also the overall management of shopping mall, stores, and the shopping experience as well. Another one is smart cities, where benefit of connectivity embedded anywhere will help build this sort of intelligence, global intelligence, that will supersede smart city functions and activities. Connected healthcare, we do want to address this market because of the growing demand from governments to reduce the cost of healthcare while raising the efficiency of healthcare, and technology such as 5G with remote access, fast remote access to big type of data in low latency can really enable to remotize use cases for healthcare application and reach out to patients in a much more efficient way. Education, we all know what happened in the pandemic, where this was one way to discover the need for next level of digitalization in the education. Agriculture is an area where there is not much technology utilized today. Probably there is much more technology that would be required, and connectivity through 5G networks, even in that domain, will help connect the dots among intelligent devices that want to interact in order to build a management system for the smart agriculture of the future. And it goes without saying that construction and mining is also an important one, because construction, there is a growing demand for monitoring health of structure for obvious reasons, and now the technology is ready to address that. 5G technology includes NSA and SA. NSA was somehow the first one launched in 2019 because operators wanted to accelerate on the adopting this technology, and that they push accelerator pedal in order to leverage 4G network to get 5G connectivity and coverage as soon as possible. So NSA, as opposed to SA, required use of 4G network. There is control and data exchange on both data plane and control plane that is managed through the 4G network. And the 4G network is instrumental to have the connectivity established, while the 5G, by the use of millimeter wave or sub-6 gigahertz, enable much bigger data pipe, mainly for enhancing mobile broadband use cases. But now with the standalone SA 5G, with a single 5G grade entire network, with a 5G next generation core network and 5G radio, can bring the experience to the next level, enabling the support of many more use cases. So the main difference is that on the left-hand side, the NSA network is much more complicated, more difficult to be managed, while the simplicity and the flexibility of the options enabled by the SA network can really open the door to the 5G use cases in the IoT domain that everyone is eager to deploy. The 5G standalone is their main building block that SA technology is enabling, and so it is the way to realize the full potential of 5G for industrial IoT. A standalone private network is an independent network that can leverage the 5G option with new capabilities, such as new security credential management options that can make the 5G private network as the real and proper communication network of the IoT industry. So the factory owner, the warehouse owner, and can really make these assets part of their system end-to-end, managing credential for the devices, managing services, and managing the infrastructure. SA technology and the 5G technology evolution will embed support of the so-called NR-like devices, which is the way the 5G standard will address the need for massive IoT, having many more endpoints connected to the private network to implement a proper sensing layer that is a building block of the entire intelligent proposition of private networks. Time-sensitive networking and TSN, so ability to have time coherence and synchronization for low-latency application in a 5G will be fully embedded in a 5G SA network. As well as 5G SA can enable the network slicing ambition to address different scenarios, because not all the countries have same level of frequency availability. So there are countries much more advanced, even in Europe, where the local spectrum is available for private implementation of private networks, but also countries where synergies with operators are required. And XOR slicing is really enabling this flexibility. But even more important, the private network brings elements and building blocks that are enabling also the ability to exploit this intelligence with the MEC, MAC, and URLC. So there are intelligence components of the private network that are supported to implement this edge compute intelligence that is required not only to communicate data, but take decision and implement predictive maintenance and digital twins as well. And last but not least is precise positioning. 5G technology is already enabling RIS 17, 16, and even improving RIS 17 and beyond the ability to have precise positioning. That is one of the major requirements in order to have full implementation of remote intelligent control of machines in a factory, for example, but also for logistics. So, three major vectors that 5G technology is powering. The one in the direction of enhanced mobile broadband with much bigger pipe, but maybe lower latency. Massive IoT, having tons of connected endpoints, building these, acting as the neurons of the intelligence layer that will be embedded in the private network proposition. But ultra reliable, low latency, every time reactive decisions through a 5G communication needs to be taken, for example, in the factory domain. We are grouping here some of the major set of requirements that in the case of Industry 4.0 are required and have to be met through the 5G technology. So on the left-hand side, we have computer vision, head-mounted display, and handheld terminals that are grouped as set of requirements that can be addressed with the enhanced mobile flavor of the 5G technology, where you need to have big pipe, you don't need to push too much on the latency aspect, and the reliability can be sacrificed, not targeting the famous 6 nines that are requested by other use cases. In case of massive IoT, the reduced capabilities targeted by RIS 17, the light NR, what is called also light NR, is exactly meant for a much more efficient reuse of network resources in the private network to multiply the number of sensors that can be deployed in the factory. So this is something that can be perfectly integrated in the SA proposition. But the very important one that in the OT industry, everyone is eager to put their hands on is the low latency. Low latency that is really the enabler of the flexible and configurable factory proposition. So in this case, the main requirement to be addressed are the 6 nines when it comes to the availability and reliability, still having a decent rate for the exchange of information and communication in the private network, but also having, very important, low latency, with a range of latency values that can span from 20 milliseconds all the way up to the millisecond. This is to cover use cases such as AGVs, automated guided vehicles, that can really benefit from the low latency in order to offload intelligence to the edge compute and perform operation with much more interaction with the sensorial environment built in the private network. More importantly, the extreme use case of industrial robots, where the control has to be aligned to the support of latency requirement of industrial communication protocols, wired industrial communication protocols. That is why the 1 millisecond has been highlighted here, but also reliability and availability of information is a crucial factor. 5G technology with SA, with RIS 16 and the evolution towards RIS 17 is embedding the possibility to support all those areas, this set of requirements and those use cases. And then transformation in the network infrastructure is another enabler, because thanks to the flexibility that vRAN and the possibility brought by MEC, those private networks are not only communication networks, can really scale in a flexible way to fine-tune and to tailor the deployment to the needs of the user, to the factory, to the warehouse, to the port, where characteristics, number of sensors, typology of devices are very diverse, but also leverage the intelligent components of this new flexible architecture in order to implement and embed low latency and reactive artificial intelligence for digital twins, for predictive maintenance, and for the control layer of intelligent devices. What is bringing SA when it comes to 5G network? Flexibility options, not only because of SA, but also for the aspects that SA technology can support, with both centralized scenarios where there is a full leverage on network elements that are remotely deployed, but also local edge scenarios where there is a deep and and strong reuse of network elements for indoor deployments of the private network, fully capitalizing also the availability of intelligent network elements developed and deployed on premises for artificial intelligence and more, or for edge compute. So, in essence, SA with this expanded proposition can protect end-to-end quality of service between devices and sandbox new services in a way that is protected in terms of KPIs, QoS, and communication parameters that are required. But also tailor with the level of flexibility supported the architecture to service-specific latencies and use cases. Also, the flexibility in positioning the resources where they are needed in the factory, but also address as many use cases as possible with this flexibility, allowing mixed scenarios that can be segmented by use case. Private networks are a strong ingredient of this revolution, where 5G is going to be the enabler of everything we just described, because they are dedicated, tailored, locally deployed, flexible, and they can be secure, protecting data, not leaving data going outside the premise, and also can be optimized with all those options to protect the quality of service that a specific end-to-end service requires for an efficient implementation. And last but not least, also the possibility to interact with public networks and to roam to public networks for much broader scenarios where the factory implementation is not only limited to the factory domain, but can leverage with geographical networks for logistics and for the supply chain interaction and even more. Allow me to share some examples of these implementations. So in the factory, in the Industry 4.0, we are sharing a snapshot of an implementation for the factory of the future. We have a private network as the communication layer connecting all those dots. And let me try to dip into the dots a bit more. We see this network capable of supporting many Ultra HD cameras for surveillance with artificial intelligence, monitoring also factory workers' safety, for example. But also we see plenty of sensors to be supported by the expanded capability of those private networks to manage many more endpoints. We see factory automation devices with the need to support low latency, such as robotic arms, AGVs, and robots in general. Another important one is the ability to support HMIs and XR. So HMIs are no longer linked to the machine itself. It gives flexibility to have mobile HMIs for factory workers moving in the factory domain in order to interact in real time with all the machines that are part of the production process. But also the ability to utilize XR with the HMD glasses and visors in order to support operations of the factory workers, to instruct them to do part inspection with the camera vision. This can be enabled by the ability to interact with edge compute in the factory domain. And the last point I want to mention is the implementation of edge analytics and data storage on-prem for protection of data and for tailored artificial intelligence application implemented on-prem, and to be complemented by the cloud as well when needed. Another one I would like to touch base and mention is the implementation of private networking ports. Give the ability to have artificial intelligence through camera monitoring operations, implementing people safety, tracking cargoes, tracking moving parts, and tracking, for example, unmanned vehicles, cranes operating in the port. Logistics is not a trivial use case for private networks because beside the expansion of sensors on shelves, of monitoring of AGVs and the robots for placement and for picking goods from the warehouse and boxes as well, there is the possibility to do real-time tracking by using positioning and communication in a private network of perishable items, for example, which is a vital point when it comes to improvement of the logistic process in the warehouse. I'm going to close on this slide. So private networks are happening as we speak. There are many big industrial conglomerates and big companies pushing for acceleration of the availability of solution in their warehouse, in their campus networks, in their factories. We are showing some example as we speak. Qualcomm is heavily involved in defining the standards and working on commercial solution, collaborating with partner in testing end-to-end those solutions. We really look forward in accelerating the adoption of 5G technology for industrial IoT. So with that said, I'm finishing my presentation, and now back to Jeremy for the next session.
Sebastiano, thank you. That's very, very helpful indeed. I would love to come first to the panel questions that our audience have been sending in, and they're good, and please keep them coming. Bob has asked, articles about 5G applications often reference autonomous driving and virtual reality for remote surgery and a few other generic markets, but can the panel suggest some more novel applications that have already been deployed? Jan, could I come to you first on that, and then maybe Jens, if you want to add anything?
Sure.
Jan?
Yeah. I think we can take basically two pillars when it comes to applications. One are these type of very spectacular lighthouse applications, which some of them Sebastiano already mentioned. And those is for sure autonomous driving fired up, or using 5G as communication with a central intelligence, or even on a car-to-car V2X type of basis. Then there are a lot of other maybe less spectacular applications where you just replace partially cables and reduce the effort of putting sensors and cameras where it didn't make sense commercially before. These are the low-hanging fruit, and they can allow also by giving you the option to capture more data, help you, for instance, to really train models for predictive maintenance better than you could before. Of course, there are a few, and I think AR is one of them. You mentioned VR, but I think augmented reality, where remote worker type of thing makes. And there are applications which are also mentioned by Sebastiano in the area of people safety, co-working humans with robots. That is, I think, one of the very tempting ones that will help to accelerate those automation.
I know we've reported on some really fascinating 5G AR applications in training. Jens, is there anything that you would add on Bob's question?
Yeah, I think that we see a lot of these very, very like what Jan called lighthouse applications, but a lot of the time it's more a question of businesses that you want to digitalize. So, for example, in the manufacturing sector where we are active, there's a huge push to integrate machines with IT systems, and also at the same time you need the machines to be mobile, so that you get the flexibility in your manufacturing. And this then drives some kind of a wireless connectivity, which is hard to achieve reliably with wireless LAN, and this is where 5G comes in, and this is also one of the major use cases that we see in deployment today. So this might not be very flashy, but it solves real world use cases.
Yeah. Sebastiano, I'd like to come to you on a different point. I know you touched on it in your discussion, but could you explain a bit about the differences between NSA, non-standalone, and standalone, and the benefits that we're going to see with standalone?
Yeah, sure. NSA is a flavor of 5G technology, requiring the use of 4G technology as an instrumental ingredient of the network in order to establish the 5G connection. So there is the use of a 4G core network that is required, 4G radio link that is established to manage data and establish a control connection towards the network from the device. While 5G is only for data, is an expansion in capacity, adding an additional bigger pipe to the exchange of information between the two endpoints. While SA technology allows to have a single 5G network with an advanced next generation 5G core network, much lighter architecture in terms of complexity, but also much more efficient architecture. Because when it comes to extreme requirements, the DOT industry is pushing the wireless semiconductor industry to deliver, everything is about mapping those KPIs, these latency and reliability requirement, to the complexity of the 5G network. Having something much more optimized in terms of complexity of the architecture, which is the value proposition of SA, is really the way to achieve and match those stringent requirements from the DOT industry.
Yeah, definitely. I think it would be interesting to understand, Jens, why is 5G SA important, and what does it mean for industrial companies?
Yeah, so this is actually one of the prime reasons why we're looking at standalone technology. So when you look at the private networks for industrial production, we see that in the countries where you have regulatory schemes that allow you to get frequencies, you only get one frequency. Whereas with the non-standalone, you need a frequency both for 5G and for 4G, because you run both frequencies at the same time. So it's really almost mandatory to have standalone when we talk about industrial private networks. So for us, this is a very, very important milestone.
Yeah. Jan, we mentioned earlier the significance of the 5G SA announcement in Germany. Can you tell us a bit about the overall importance of this, Jan, and what does this mean for the region as a whole?
Yeah. Yeah, that's a very good question. I think basically here we see in Germany now the 5G SA being launched in the operator network, but also the 5G SA being deployed in private networks. And here the regulator made a big move about a year ago to really set 100 megahertz out to the enterprise sector with a very easy to apply for type of mechanism. And also they gave it away, let's say, at a very good price, I think. So firing up the need or the, let's say, firing up the use cases to be deployed in enterprises. And at the same time, the network operators, of course, also see the advantages of 5G SA for certain use cases in a public network. 5G NSA makes also still a lot of sense in terms of reuse existing assets, as Sebastiano said earlier, and operators can deal with that complexity, of course. But the step to 5G SA also in public networks, of course, is now hopefully also driving the development of the ecosystem in terms of chipsets, etc., into a larger scale and towards a lower and more business deployable type of price, right? So I think that this is really a very, very good move forward, and I hope it creates kind of an avalanche effect also to other countries.
Yeah. Sebastiano, is there anything you would add on that?
Yeah, I would like to add something. And Jan did a provide a very good analysis of importance of those milestones on SA technology. Let me say the SA technology and the milestones is a way to testify the readiness of the technology, not only on the chipset side, or Qualcomm side, but also with all the great infrastructure partners such as Ericsson we're working with, because the technology is available right now. For example, when it comes to chipset that are the ingredients powering the connectivity on the IoT devices, we already have public chipsets announced on Release 16 support of SA networks, such as the SDX62 and 65, and the technology is commercial. Those can be utilized today to address those scenarios. Even the SDX55 can support SA networks in various scenarios. What we are even doing, we're trying to scale. So it's not only a matter of readiness of the technology, but shaping the technology in order to be compelling and attractive, and fitting and matching the cost structure that our customers are expecting. That is why in this direction, one way for us to address is the announcement that was issued 1 month ago on the availability of new IoT chip, 5G IoT chip called QCX315, that will support and will be validated in private network scenario with SA, with a lighter cost structure. This is a move from us that we want to pursue and promote in order to start helping to the second generation of 5G IoT devices, scale the cost structure in order to expand the adoption of 5G technology for more and more use cases.
That's really helpful there. Thank you very much. There's a great question here from Mukesh. Jens, I wonder if I could put this to you first. Mukesh is asking, can you please share some more details on some of the prominent MEC use cases?
Yeah, I'll have to ask exactly what is MEC?
Edge computing.
Okay. So this is a very, very good question. So we see that now with the 5G, we have strong connections between the devices in the field and the IT or cloud systems. So this means that you can move a lot of the computing to the cloud with minimal latency. But we also have a huge thirst for video and 3D sensor applications. So many people see that if you deploy cameras, for example, in a production facility, you can monitor different aspects of the production. But then in order to get high resolution, you really need to stream a lot of data from the camera to the cloud. And then if you deploy a lot of cameras, you run out of bandwidth on your 5G network. So in this case, it's a very, very good example of why you need the edge computing on the device, basically in order to do the pre-processing before you send the data to the AI systems in the cloud.
Yeah. Jan, do you see differences between the rollout or the applications as well, spanning different European countries?
Yep, for sure. I think when it comes to public network rollouts, of course, this is driven by the operators and also by the authorities or regulators assigning spectrum to the operators. When it comes to industrial spectrum, like we have in Germany, we see that now coming up in various countries, like we have it in Germany, UK, France, Sweden is upcoming. I think some other countries might come a bit later. For both for the public frequencies as well as for the private or industrial frequencies. So I think Europe as such has a good chance here to build a bit of a industrial thought or technology leadership by being fast as a European unity, so to speak. Because we may be not in Europe the leaders in cloud applications or stuff, but on 5G, I think we have a very good potential to be on the forefront. But there are other countries and regions that are catching up or even overtaking. So I personally think we should really speed up even more.
Yeah. Sebastiano, would you add anything to that about the differences between not only European countries but worldwide?
Yeah, so I second the point that Europe is on the driving seat. Probably Germany did a great job in coming up with a solution to address need for spectrum for the OT industry, and everyone is trying to follow up, at least to discuss the problem. Because there are markets where this is not materializing as of yet, but there are discussions with the Ministry of Interiors, with the Ministries of Industry, in order to understand in which way leverage this technology revolution for the national industry. So this is a good point. And Europe is much more advanced. Now there are ongoing parallel discussions in the US market how to capitalize the availability of the CBRS technology and spectrum to be expanded also for the 5G technology. And similar discussion are happening in Asia, actually. But I want to stress and reiterate one point, that we need to be fast. And we need to be fast in order to, how to say, in order to make sure that the strong assets we have in the OT industry in Europe can also expand the leadership by bringing the new technologies as an expanded set of capabilities for which our industry is well recognized worldwide. And we have the opportunity to do that. Just take a look at what is happening in Germany and happened already in Germany. We did a lot of activities, but not only ourselves. In Ericsson, there are great collaboration with HMS as well on trial and integration in commercial products of 5G technology for already deployed use cases that are up and running. And there are factories built and embedding 5G technology that are operating machines as we speak. And this is real. We started 3 years ago, maybe 2 years ago, and there is a roadmap for more and more trial activities and pre-commercial factory deployments with some of the new characteristics of the evolution of the 5G technologies that are being deployed as we speak. Yeah. So this is a great opportunity, not only for our industry, but for the entire Europe as well.
Good question here from Ignacio. I'd like to start with you, if I may, Jens, but if you feel I should direct this also to somebody else, then feel free to say so. The question here, Ignacio says, what does the regulation say in Europe for using frequencies for 5G private networks? It's a broad question, but I mean, could you have a stab at that?
Yeah, and I think Jan already has addressed at least part of it, because we see that in Germany we have a strong regulation where you can get access to 100 megahertz of spectrum in the 3.5 gigahertz band. We have a similar situation in a little bit different frequency band in the UK. And then we have different countries have different approaches. For example, in Denmark, there was an auction recently where you licensed the spectrum to an operator, but then the operator have an obligation to sub-license the spectrum to whoever wants to build a private network. And then we have Sweden still developing, but actually in Sweden we have the situation where one of the operators has sub-licensed part of the spectrum in 2.6 gigahertz to a specialty operator that then addresses private 5G network use cases. So I think we see this developing country by country, and each country has a slightly different approach, but all the time we're getting better and better coverage for getting private 5G spectrum licenses.
Yeah. Sebastiano, I know that you've addressed this already in your presentation, but that was necessarily brief. Could you give us a little bit more to answer Barry's question? He asks, within the private 5G network, of course, how is the data protected against the possibility of unauthorized access and modification?
This is one of the key ingredients of the value proposition of private networks and 5G technology. So data can be stored on-prem. There can be MEC endpoints. There can be edge compute devices. There can be servers on-prem storing data, analytics, information from the endpoints, from cameras, as Jens mentioned before, but from robots, from the entire layer of sensors, maybe to implement predictive maintenance in the factory. Everything is stored locally, is not leaving the factory. And even the management of the credentials for the devices can be fully managed by the factory owner working with the supplier of the private network, or even working with the operator. There might be ways to protect information about the device credentials. And in general, there is the most secure technology is when it comes to communication, is the 3GPP1. The security level of security has been improved and increased in 5G, and this is secure by definition. And then working on hardware that will capitalize this security, expanding on this security by having unique features for the industrial IoT market, such as storing hardware credential in the hardware itself, instead of having software credentials, and leveraging this root of trust to authenticate the device. So everything is happening in the hardware, on-prem, is not leaving the factory, can be fully controlled and managed by the private network and the owner of the asset. Data on-prem, and all the use cases where it really makes sense to manage huge amount of data in low latency through devices deployed in the factory, so they are not leaving the factory anytime, unless there are use cases where access to the remote cloud is required, as some of my colleagues mentioned before. So in this case, this can be implemented also in a secure way, so everyone is familiar with the cloud, so you know how this works. But there is very high level of protection for data that the private network proposition is embedding.
That's really helpful. I'd like to throw that over to you as well, if I may, Jan. Is there something that you could add to that?
Yeah, I think Sebastiano almost said it all, but I think the question is, how is it protected within the 5G network? So 5G has, as Sebastiano said, even improved the security on the air interface, and also in the way the nodes interact and authenticate each other compared to 4G. And I think here we see at the moment one of the most secure. There is no 100% security in the world anywhere, but I think it's one of the most secure wireless systems that you can find at the moment at an affordable cost of price, right? And then, of course, the rest is up to the IT security of the enterprise. But I think here we have, compared to Wi-Fi, compared to some other wireless technologies, we have a very robust and secure technology that can be used for so many purposes that it really makes sense to build a foundation on that.
That's certainly true. Martin has a question here that I'd like to put to you, Jens, if I may. He's asking, how do you keep a private 5G network from interfering with public or other private networks? And conversely, how do you protect a private network from outside interference? What would you be able to say on that?
So I think that for example, in Germany, where you have a dedicated frequency range for private networks, it's quite natural that you have kind of islands where you use this frequency band, and then there's no public networks that use the same frequencies. So in this case, you have a kind of a natural separation between the private networks and the public networks due to the frequencies that are used. But then also in some cases, when the public operators provide the frequencies for the private network installations, the public operator will make sure, as part of the radio planning, that you don't have this interference between the public network and the private network.
Sebastiano, I want to come back to you for a question from Rodolfo here, who says IoT, he comes from a telco background, he says IoT will be more efficient and powerful with 5G NSA. This is very clear. What is your view in highlighting the challenges in managing the IoT connectivity? How do you feel about that?
Well, I believe he was meant to refer to SA, but in general, yeah, we understand that moving from Wi-Fi, which is some sort of predominant technology in the factories, to 5G, there is some level of complexity. But I also have to say, and Ericsson can testify that there is a strong industry effort and initiative that is meant to evolve the architecture to make them digestible by the OT industry. With the right tools, with the right level of support, they can be utilized by the OT industry to embed those new assets in the factory, for example. So there is an effort to move away and push away the complexity from those who are focused in a different business, manufacturing parts, right? And this is the industry objective that is an effort that is ongoing. So I believe with the support of infra vendors that will be selling this infrastructure to the factory owners, for example, there will be not only effort to deploy, but also to optimize those networks with artificial intelligence, with orchestration in order to reduce the complexity of making efficient the communication for different use cases. But also there are managed services that can be offered in order to overcome and hide the complexity away from those who have to focus on other stuff.
Jens, I want to come to you for this question, if I may. The questioner is asking, how do we see NR Light's potential in the 5G IoT space?
Yeah, so this is actually one of the technologies that I'm really looking forward to, because now we have Standalone introduced, and then one of the evolutions of Standalone is that we will get what we call the NR Light. So NR Light is really a scaled down version of a normal Standalone, but it brings down the complexity of the devices a lot. So it means for us it's a more competitive price for our devices, but it's also lower power consumption and lower heat generation and so on. So it means that we have a lot of use cases where you need the high speed or the ultra low latency, but there's also a huge amount of applications where you can do with less bandwidth and longer latency. And this is what we will be seeing address with NR Light. So I think this is really a very, very important evolution that we'll see going forward.
Thanks, Jens. Jan, we've still got a couple of minutes for questions. So if I could ask you to keep your comments to a long question as short as possible, we might squeeze another one in afterwards. Scott asks, isn't the key benefit of 5G SA core architecture that it's service-based and thus allows network slices to be programmed into and out of existence by its accompanying orchestration system? Perfect, he says, for unusual IoT data use cases and efficient use of your under cloud. Big question. How can you answer that in 30 seconds or so?
From an architecture, 5G architecture standpoint, I think this is true. I'm not a slicing expert, but what I see, of course, is network slicing will mainly benefit for the time being the public networks that will allow public network operators to create a slice for enterprise. Within the enterprise, you might be more after separating traffic and guaranteeing different classes of the different service classes to your applications.
Sebastiano, is there anything that you would add to that?
Well explained by Jens, so no need to add. Maybe you can focus on next question.
Good. Let's move on. Time for one more. I'm going to put this to you, Sebastiano. When 5G brings in a massive change in latency, Kamal asks, will edge computing still make sense? Broad question. How would you answer that in a minute or so?
This is a very good question. Actually, this is a much more complex environment than having communication on a new technology with a phone, with a computer, with a tablet. We are trying to reconnect a world of things that are doing almost everything. So there is not a single requirement. the need and level and threshold of intelligence, and need and level and threshold for latency is very different use case by use case. So we do need to incorporate and integrate low latency as much as possible with TSN. We are working on that in order to cut the wires, to give this flexibility. But this communication and latency is needed to have strong intelligence with a big pipe that can sit very close to the end device, but can stay a bit farther from the end device because need to collect information and analytics from many more endpoints and cameras. So the architecture and options and layers and distance from the device are really part of a matrix of multiple options. That is why AI, MEC, and are needed. They really need to leverage on low latency in order to have no barriers and constraints anymore on use case you can target. But this is a complete matrix of use case and KPIs and performance levels that all have to be integrated in parameters.
Thank you. Jens, I can only give you 30 seconds, but what would you say in follow-up to that?
No, I think it's important to realize that when we talk about edge computing, people understand different things. So to some people, like us, we believe that edge computing is actually on the device that sits close to the machine, whereas to other people, edge computing is in the building or close to the base station. And I think it really matters. It really depends on the application that you're looking at. Some things clearly belong close to the sensors and actuators. Some things belong behind the base station, and then other things belong all the way in the cloud.
Yeah. Fair enough. I'd love to carry on the discussion, but gentlemen, we've been given some really great questions by our audience, and I want to thank them for that. I am afraid we are out of time. So to everyone watching, don't forget, please bookmark our site at iot-now.com. And there you'll find the latest news, videos, blogs, interviews, and so much more. And of course, from tomorrow, you can stream this webinar at the site too. It just remains, therefore, for me to say a big thank you to our speakers. Sebastiano Di Filippo, it's been great to have your input, Sebastiano. Thank you.
Thank you, Jeremy. Goodbye.
And my thanks too to Dr. Jens Jakobsen. Thanks for being with us, Jens.
Yeah, thanks for having us, Jeremy.
It's been great. And my thanks also go to Jan Diekman for sharing your enormous expertise, Jan.
Thank you very much. It was a pleasure.
Great to have you all. Most of all, ladies and gentlemen, I want to thank you. Thank you for joining us around the world. Your attendance is very much appreciated. Please keep safe, and we really mean that more than ever these days. From everyone here at IoT Now, bye for now.